Hello, my dear friends. Today we are here again with a new lecture on a new topic which is actually covered in the syllabus of ninth class physics, science, and it is nothing but gravitation. Many of you might have heard this word gravitation. Okay. Sometimes you have also heard a new word called gravity. And many people on this planet may think, and even they think also, that gravitation and gravity are same. No, these are not same. As we will progress into this lecture series of gravitation, we will find that gravitation is different, gravity is different. This is a force of gravity, this is a force of gravitation or gravitational force. There is a huge difference between these two. These are terms used for different things. How? I will give a very small idea, and then as the chapter will progress, we will go into detail that what is the actual difference between gravitation and gravity, right, in mathematical terms and in physical terms. Let me tell you simple difference in a layman language. Let us suppose there are two objects, say you. You mean you, like you are sitting in a room, okay, and then there is your sister, okay. So there are two objects, two bodies, one is you and other is your sister. Fine. Now, what is the distance between these two? Like say 1 meter. You are sitting 1 meter apart, no problem. Now, gravitation means the force of attraction between any two bodies on the earth, or the force of attraction between any two bodies anywhere in the universe, right? And this force is called as gravitational force. Now, if one of these two bodies is earth, say this is not your sister, this is earth, say this is earth, then you mean yourself and this is earth, there is a force of attraction which is called as gravity. Okay, so in simple terms, your sister will also have a force of attraction known as gravity. So between earth and your sister there will be a force which is known as force of gravity, and between you and your sister there is a force which is known as gravitational force. So can you tell me what is the difference between these two? Very clear, very obvious. Whenever there are two objects or more than two objects even, then there is the force of attraction between these two objects known as gravitational force of attraction or gravitational force or gravitation. And if one of these two objects is earth, mean the force between the earth and and any other body is called as gravity. Okay, so clear difference is when there are two bodies, 1 and 2, the force of attraction between these two bodies is called as gravitational force. And if one of the two bodies is earth, it is earth, or number 1 is earth, whatever you like, then this force is called as gravity. Okay, so for gravity, the second body must have to be earth only, that's all, right? So let us find how the things are related with this gravitation, how the forces are related to gravitation, how we can find out the force of gravitation. Is there any method? Yes, there is one method by which we can find the force between any two bodies. Yeah, like there is a school, and in a school, in a class, two students are sitting on a bench. this is you and this is your friend. Do you know that? There is a force of attraction between you and your friend. And even let me make it more funny. There is a force of attraction between this desk and this desk also. Okay, any two objects. Okay, there is a force of attraction between the teacher and the students also. This teacher and this student also. This teacher and this desk also. Now, a question may arise in your mind. If there is a force of attraction between every two bodies, why these bodies are not stick together? Why don't we feel a force when we are sitting in a room? Like if in a room we are sitting with our sister or mother or father or whatever is there, why don't we feel that force which attracts towards each other? Let us find why. This why is very important because why gives you replies for many things in the life. Okay, so let us find this why here, why it is so. So for that why, Newton's, like you have heard the name of Newton, Newton's gave a universal law of gravitation. So today we will study Newton's universal law of gravitation, in which we will find the answer that how much is the force which is acting between the two bodies, okay, which is of gravitational force of attraction, right? Let us find out universal law of gravitation. What does it says? So according to Newton universal law of gravitation, let us say there are two bodies, say A, and there is another body, say B. Let the mass of this body is capital M and mass of this body is small m. Say this is you and this is your sister, little sister. Her mass will be smaller, that's why written small m. Okay, just a notation. You can also take m1, m2 also. Okay, in some books you will find m1, m2. In some books you will find capital M, small m. Doesn't make a difference. Mass means m, that is denoted by m only. Okay, A and B are the names of the bodies. Okay, like Amit and Bharti. Anything can be there. Now let the distance between these two bodies is say r. Okay, they are separated by some distance, say r meter. Okay, this r may be 1 meter, 2 meter, 3 meter, or it may be in centimeter also if you're sitting close to each other. Okay, so now Newton's universal law of gravitation says that there is a gravitational force of attraction between these two bodies, and that force of attraction is proportional to, directly proportional to product of the masses. Equation number 1. Now let me explain this. When I say directly proportional, you know the meaning of directly proportional? When this quantity increases, it also increases. When this decreases, it also decreases. So there is a direct proportional change. When the masses are more, mean these objects are very heavy, like two train compartments, okay, of 10,000 kg, 10,000 kg, then this force will be larger. And if you are there, you and your sister, 70 kg and 40 kg, let us say your sister is 40 kg and you are 70 kg mass, then this force will be smaller when you compare it with two trains which are 1000 kg, 10,000 kg and 20,000 kg or 10,000 kg again. Okay, so this is the meaning of directly proportional, right? So when this quantity increases, this quantity also increases. When this decreases, this also decreases. Simply, the meaning of this sign is direct proportion, mean when it increases, it increases, when it decreases, it decreases. I have proved also. It's IQ, simple IQ. Second thing, Newton's told that this force is also inversely proportional to this square of the distance between these two. Now, what is the meaning of inversely proportional? Inverse proportion means when R will increase, F will decrease. And when R will decrease, F will increase. Inverse. Okay. How? It means when the two objects are far away, say 1 kilometer, naturally the force of attraction will be less. When they are very close, the force of attraction will be more. Simple. So, inverse proportion mean when this quantity increases, this decreases, and when this decreases mean they are near to each other, then force increases. Now combining these two, F proportional to m1 m2 upon r square. When we remove this proportionality sign, we put equals to and some constant. This constant is capital G here. I will tell you what is this. m1 m2 upon r square. This is the force which is acting between two bodies of capital mass M and small mass m. Right? Now what is G? This G is called universal gravitational constant. You know its value because it is a constant. Its value do not change at all. Whether you go to London or you go to anywhere in the universe, its value will remain same, and that is calculated by a scientist Henry Cavendish like few years ago. 6.67 10 to the power minus 11 Newton meter square per kilogram square. This value must be learned by heart. Okay. How this unit came? Very simple. You know, this is F equals to G m1. So what is G? Send r square here. Simple algebra. So F r square upon send m1 m2 here. m1 m2. What is the unit of force? Newton. What is r? Distance. Distance is in meter. Meter guna meter, meter square. Right? m1 kilogram, m2 kilogram. So it's kilogram. So Newton meter square per kilogram square. This is the unit of capital G, right? No need to cram. Just cram this value because it is a constant value. Now just look at this value. This is 6.67 10 to the power minus 11. Very, very small. If it is plus 11, it is large. When it is minus 11, it means 6.67 divided by 1,000,011 times. And when you divide it, it will come out to be 0.6, 0.00000067. Very small value. And this is the reason because G is very, very small, the force of attraction between any two bodies is very, very small. That's why you cannot feel this force of gravitational attraction between you and your sister, or between you and your desk, you and your table, you and your wife, anybody. You cannot feel that force because it is very, very less. Due to the less value of very, very less value of G, right? It's very less value. So, can we use this law somewhere? Yes. Name suggests universal. What is the meaning of universal? Universal means anywhere in the universe, whether you are talking about terrestrial objects or interterrestrial objects or objects on the earth, anywhere this law is applicable. Means you can find the value of force between any two bodies, like between moon and sun. What is the requirement? If I give you assignment that beta go and find the force of gravitational attraction, gravitational force between moon and sun, you know what will you require? You will require mass of the moon, first body, m1, m2. Here I have taken m and capital M. I have taken m1, m2. You can take it m1, m2, so that I don't have to change here. Okay, you can take m1, m2 because I have taken here m1, m2. Otherwise, you can take m, capital M, small m. Then here will be capital M, small m, capital M, small m, capital M, small m. No problem, because one and each and everything is same. It is your nomenclature what you are calling them. Okay. So if you're taking moon as the first body, the mass will be m1. If you're taking sun as a second body, mass will be m2. So you must be knowing their masses and distance between them. That is fixed. You can check from internet what is the distance between sun and moon. You can find out. What is r? And you know what is our distance between these two? So G is fixed, given. You can find out force very easily. Even you will get some sort of numerical problem very soon from this chapter, which will be using this formula to find out the value of force. Okay, it's very simple. So, you know where it is used, where this law is used. Just look at the law. This law basically tells us that every time there is a gravitational force of attraction between the two bodies, whether it is on the earth or in the universe or it is terrestrial body or anything. Okay, so you know tides, why tides comes? Because there is attraction between water of the sea and the moon. Okay, due to that tides come, there is a gravitational force of attraction. Similarly, the moon is a natural satellite of the earth which is orbiting around the earth. This is also due to this gravitational force. If gravitational force do not exist at all, they will not move, they will not rotate around the earth in any manner. Everything will be shrinked. Okay, and there will be a kind of big bang in the universe. So this force is very responsible force which is in between the any two bodies on the universe, in the universe, or whether you go to terrestrial objects or whether you go to some earth objects or anything. Okay, so we will take one numerical, very small numerical, which may be given in the book of ninth NCERT science. Then we will conclude this chapter, right? So there is a numerical. Find the value of gravitational force between moon and a planet X. Okay, the mass of moon is 6 point something into 10 to the power something given. Mass of the planet is given, and the distance between them is also given. You have to find out force. You know what type of formula you will use? Same, Newton's universal law of gravitation. So Fg m1 m2 upon r square. G is fixed, 6.67 10 to the power minus 11 Newton meter square per kilogram square. And m1, what is m1? m1 is the mass of moon. Put it here. m2, mass of the planet X, and the distance between them, that is given to you. You can find out the force between them. This kind of numerical may appear in the examination also. It's very simple, formula based numericals. Okay, so tomorrow we will go for something detailed, that is the new term called gravity, and then we will find a relation, because gravity is denoted by small g and it is capital G. We will find a relation between this and this also. Okay, we will discuss in detail. This is a very important, easy and interesting chapter because it relates life actually. You know, when there is no gravity, there is no life. When there is no gravitational force, nothing will revolve around the earth. Earth will not revolve around the sun in any manner. So life will come to a halt, will come to an end. So it is very interesting chapter if you study it seriously. Okay, so this is the end of today's lecture, and we will meet you in the next lecture. We will doing something about small g, mean gravity, and then we'll find a relation between them. We'll do some numericals and discuss some more things also. Okay, so I would request you to please subscribe to my channel if you are new to my channel, and if you have any doubt, you can ask from any time using my mobile number, which is given in the description, and also you can post some comments if you like this chapter. Okay, and you need to press bell button, and because if new notification comes like new videos posted, you can get the information about it. Okay, so thank you very much, and thank you very much for the patience hearing. Thank you.